My name is Jack Harper. I'm with Secure Outcomes Inc. out of Evergreen, Colorado, USA. And what I want to talk about is something near and dear to my heart, especially after raising a little bit of money for a company, namely betting your company on Lisp. And obviously, if you make the decision to use Lisp to build a commercial product, and if you have trouble doing that, in particular because you made the choice to use Lisp when you're surrounded by venture capital investor types saying, oh my God, what are you doing? You have a problem. So, it was a fundamentally important decision to do that. Who is this guy? Well, I've been in the Lisp world since 1971. That's when I wrote my first piece of code. I found John McCarthy's book in the university library, and I was an assembly language programmer back in those days when I was, young. And that was my thing on a UNIVAC 1108 and big mainframe. That was back in the good old days when computers were measured in significant fractions of a hectare, and kilowatts of power. The UNIVAC 1108 was a truly wonderful machine, at least to me. Again, the thing was enormous. I lived in the computer center, and I'll never forget because I finally got a job working there, and I had the midnight Sunday shift from 0001 till 0800 Sunday morning. And after I'd been there a while, I finally got my nerve up and walked up to one of the cabinets on that thing and opened it, thinking, wow. And to my astonishment, it was empty. But obviously the entire machine was not empty. It was just that part of it. But my start in Lisp is reading McCarthy's book, and I remember it vividly. Because again, coming from the assembly world and then reading that, I just could not believe it. My God, what is this? So of course, this is before I got the job at the computing center. So I went and said, hey, I want to run this thing called Lisp. And of course, they all stared at me and said, we have no idea what you're talking about. But I finally found the Lisp implemented by a guy at the University of Wisconsin. And so I sent him a half-inch computer tape, and 2 weeks later, the thing showed up. So I installed it on the UNIVAC and made a deal with the powers that be that it was part of the standard repertoire. And then I was responsible for keeping it alive, which I did for the next several years. And I learned so much more from doing that than I did the rest of it. I actually majored in electrical engineering. This was, of course, back before the days of computer science. And anyway, I learned more doing that than any of the EE computer classes that I took. That is for sure. Later, I did something else that was interesting. I implemented on a 68,000 Motorola, and of course, assembly language, 50,000 lines, and a year later, a Lisp system running on that thing. We built a mobile security robot back in 1984. We had 4 68,000 processors, obviously all running in real time. In fact, there was no OS. So the code that I built was actually just running on raw iron. 68K, 4 of these things running this version of Lisp, which was, bastardized, for lack of a better term, bad word, version of Lisp machine. Anyway, a lot of fun. I got a gaggle of patents, in crypto and AI. For fun these days, I collect Lisp machines, symbolics. I've got a couple of 3650s. I don't know if you've ever seen one of these things, but they're big. They're also incredibly noisy. You power them up. They chew up about 500 watts of power each. The 3650 has 9, I think, fans in the bottom base of the thing. Guy right there nodding vigorously. Anyway, you power both of them, and it sounds like, the Army is coming with helicopters. But anyway, I've got a couple of 3650s. They're fun to play with. They are astonishingly slow. And then a 3620. They are, in fact, about 1,000 times slower than, this laptop, as you can imagine. The symbolics machines really were designed in the very late 70s and using LS74, whatever it is, logic, TTL. But anyhow, it's slow, but very beautiful stuff. Also, I've put together a couple of companies. I do these about once a decade. This gray hair came from somewhere. But the first one was a company called Topologics back in the 1980s, and we built a very interesting thing, a parallel mini supercomputer with 128 processors running Lisp and then C. But that was certainly a lot of fun. And then after that, another couple of startups. And what I'm doing these days with a company called Secure Outcomes, again, this is what I'm doing this decade. With Secure Outcomes, we've built a very small, inexpensive digital fingerprinting system for law enforcement, government, people like that. But we scan fingerprints, so-called full-rolled forensic fingerprints that stand up in a court of law. This stuff that we collect, we're on one side of the big national databases, so we collect the prints that feed the FBI and Interpol and people like that. And then our market is not large governments. I stay as far away from them as I can. Our market is actually local law enforcement. To give you an idea, in the United States there are 23,000 local law enforcement agencies, police, sheriffs. Those are the low-hanging fruit. And in order to make this company work, and one thing I learned is that if you don't make your early stage to use with a color touch screen, so instead of typing DOSy-looking horrible commands to this thing like the competition does, you do everything like a high-end telephone. Pretty obvious stuff, but apparently not in that market. Touch screen, color, GUI, all of that drives the product that we do. There are obviously no type commands. And by the way, that's a big thing in the law enforcement market, so-called officer safety. If you're booking somebody in for murder, rape, whatever, at 0200 Sunday morning, the guy's drunk, throwing up all over the place, all of that, that's the real world. And you're trying to deal with this guy. So the last thing you want is to have to be paying attention to the machine. You want something extremely simple to use that you can't screw up, that's very intuitive. And that's a big selling point. It is. So how do you build a thing like this? And my answer was gulp, big gulp, let's do it in Lisp. And so this is the competing systems. Again, they're expensive. They start at $32,000. These things are huge. That is the size of, that's the fingerprint scan device. That's a monitor. This thing is like that. Give you an idea. And again, they start at 32K. They're hard to use. They come with a 250-page user manual. They have, for God's sakes, a foot pedal. You have to step on a thing, to tell it when to start the fingerprint roll. And the astonishing thing to me is you have to step on it again to tell it you finished the fingerprint roll. Well, I didn't want any frigging foot pedals or any of that. So we built what we built. And the key is that our system is small. It's 1/3 the cost, easy to use, portable. And of course, customers, the cop, they couldn't care less, but, the thing is built in Common Lisp. A fun side to me, market acceptance of a thing like this. Can't really see it, but, we've sold about 50 of these things to date, and actually we're selling them, what I like very much, faster than we can manufacture them. And the goal is to ship hundreds in 2012. Another slide that I like, again, I like being invited back to the party, you can actually build a company using Common Lisp and actually end up with, these are small numbers these days, but a market cap, went from zero when the company was me writing code madly at 0300 on the kitchen table to the irritation of my wife. But you see where it's grown up to most recent valuations about $8 million. And the investment banker guys tell me that should triple in our next raise, which will be in Q1 of 2012. But the decision up front, all in Lisp, yes or no? I will not really talk about, I've got a slide on it, but why Lisp? I won't even go through that in any detail. It's obvious to me, but what I want to talk about is what happens, in the real world, whatever that means when you do that. Is it, this or is it that? And talk a little bit about our experience. These at the beginning were the known unknowns. I love this stuff, known knowns, known unknowns, unknown knowns, unknown unknowns. Those are the real fun ones. But anyway, these were the known unknowns that I had to deal with at the get-go. Number one, and to me it was the most scary of all of them, is simple stability. Are you going to build this thing and then, after running in real time, hard real time, video hard real time, will the thing just crash after 35 minutes, out of the blue, drop dead, and you have no idea why? To me, that's the scariest thing. In particular, building real-time systems with users banging away at this thing. Again, think of the cop at 0200 dealing with the drunk throwing up everywhere, trying to fingerprint a guy, a rapist, whatever, and the thing drops dead. Number two was speed. We're dealing with fingerprint images, which can be quite big with a so-called four-finger flat slap coming across in real time, and dealing with that in Lisp. Will that really, really work? The other thing I found really scary was the delivery mechanism. What that is where you take all the Lisp code, running on a PC development environment, and there it all is in all of its glory. And you have a process in most systems called delivery, where there's a thing that grabs all that code, crunches it down into a blob of an executable binary thing that actually runs on the target hardware. Does that really, really, really work? To me, that's the sort of thing that's inherently buggy. It may not be tested very well because nobody builds commercial systems in Lisp anyhow, so why test that, right? We can depend on poor Jack to test that. What about the GUI stuff? This very heavy GUI stuff. Again, everything we do is based around that. What about libraries? That's a very common critique that I hear of people that say, obviously, you're nuts to try to build commercial products with Lisp because there are no libraries. What about people? Can you actually, honest to God, when your life depends on it, can you really, really, really find Lisp programmers? And I'll talk about these things. All of that going on when, again, this is what system consisted of. That was the hardware at the time. It's called Styrofoam. Little Styrofoam model that I built, sticks and glue. You can see the LCD display. There's the fingerprint scan device. That's the processor board. That's the battery power pack. This thing, again, is portable. Batteries, by the way, come to find out, are incredibly complicated things. I had no idea. You unplug a laptop from the mains and it continues to work. Come to find out, that's a involved process of making that switch over. Number two, batteries are different on how you charge them. Come to find out that's a function of temperature, current draw, where you are in the charging cycle, and it varies across all the different batteries. All the different batteries, you charge them differently. I had no idea, of course, but now I know more about batteries. we finally settled on some weird thing called a nickel metal hydride battery. Come to find out, you have to get certification in the United States and here in Europe, in the U.S., from something called the Department of Transportation. That's a federal agency in order to ship the crazy thing on airplanes, you know. So you stumble along, but and get through all that stuff. Also, all of that, are you really, really going to do this in Lisp when you got to move that to real hardware? There's our production line. You have to get that thing into production. We contract out manufacturing, but there it is. And then to the end user. That's a big federal penitentiary in outside Marion, Illinois. That's a nasty place. I don't recommend it. Oh, and by the way, software, well, there ain't none. You know, that's exciting. But I finally figured out, I think, yes, we will use Lisp. Well, then the question is, which Lisp? And previous speaker pointed out, obviously, there's a bunch of these things floating around. And so I settled on LispWorks and want to say a few words about that. Why? I'll tell you the number one reason, it's not even on here, is I did not want to go with a free Lisp. I wanted something where, you know, I pay for the system. Number two, you know, they help me, and LispWorks has been outstanding on their technical support. Poor Martin Simmons, there, you know, I talk to him frequently with, although it's dropped off, you know, over time through my learning curve and all the rest. But obviously, I did not know that at that time. But then what I looked for was a good development environment. A biggie to me also was no license fee per unit. You know, I have to make a profit, stay in business. So do they, of course. I understand that. But if I can ship systems without having to pay, you know, a per unit license fee, that's important to me. It is. Stable active testing. Again, that was a biggie to me. My God, will this thing really, really work on the long haul? Because these systems that I build tend to stay up for years and not be turned off, that sort of thing. And so I did as much testing as I could. And I'll talk about that. Well, in fact, this sort of really basic testing, I can't read that, but I did this in the lab, and give you an idea of what I would do is a very simple Lisp function that just builds a really big binary tree. You know, 2 to the 20th, 2 to the 30th nodes, that kind of thing. Let the thing run. You know, fill up a gigabyte of memory. You know, and let it run for a day and massage that tree. And if it can do that, you know, and then start hammering virtual memory, which it did, it's very interesting to watch. But I finally figured out, you know, I think it is stable enough. And the thing that really impressed me was the fact that I never have had LispWorks crash out of the blue. I've had it crash out of the blue because of my problem, you know, subseq or some crazy array problem or whatever it is, but I've never had LispWorks, the system itself, even after the delivery mechanism running raw binary on the target hardware, it's never locked up, hung up, any of those nightmare things that I really feared. The other thing was, of course, somebody mentioned before a thing called Cappy, which is the GUI development environment, graphics, all that. And the thing that I very much liked about it was the fact that our target hardware is, at the moment, Windows, something called Embedded Windows XP, special version of Windows XP with a very small, you know, it's designed by Microsoft for electric toasters, you know, small footprint, that sort of thing. And the good thing is, to the development guy, it looks just like, almost exactly like standard Windows, but it loads in less than a gigabyte, that sort of thing. But I could easily move the whole thing to Linux, and the reason I did the Windows thing up front was because of device driver issues. But we'll be moving the whole thing over to Linux, in about a year, and that was important to me. And the point of that is Cappy pretty much will just move all your application code over to Linux without some horrible nightmare. And I ran all these benchmarks. The other thing I like about ListWorks is the level of documentation. I mean, it ships with a lot of documentation, which I appreciate. Just as an aside, I know you can't really read that, but this is some of the benchmark stuff running on the actual target hardware, and it's growing by powers of 2, the benchmark and the amount of work. And the odd thing I found is that it would go from 1 second to 4 seconds to 3 seconds. It actually dropped when you doubled the amount of processing required. So don't believe anything that you read about benchmarks. They're all lies. This one, I think, is the only truthful benchmark on this planet because it shows a very non-linear thing, and I think it's real world. Well, it is, but I have no idea why it's doing that, and the only thing I could figure out is some god-awful weird caching thing, which I point out does not make any sense because the cache is there. Obviously, it goes faster, but if you double the amount of processing, surely it's not going to go that much faster, but I don't know. I'm much stronger in software than I am in hardware. And, of course, it went from 3 seconds to 60 seconds when you doubled it. And that, of course, that is kind of clear to me. I ran out of physical memory, and so started pounding away at the virtual memory, which makes sense. Anyway, point of all that is, I put all this stuff pretty much through its paces. This is photos of, stuff wired together in the lab. There's the processor board. We use a small single board computer, little bitty thing, but it's actually quite expensive. It runs close to $1,000 for this thing, but it's got extended temperature range. The other thing I like about it is we use the Intel Atom processor, which is Pentium, but it's got a small bandwidth data paths internal, which created some problems I'll talk about briefly. But the thing I like about it, I love about the little Atom, is that our entire system power requirement for this machine is about 10 watts, which is remarkably small. I'm really astonished by that. I mean, it's 1/10 of the power of this laptop. And if you're building a small mobile device without an R&D budget, $1 billion, I mean, you can really get in trouble over heat, temperature, and before you know it, you're written up on CNN for exploding devices and all that stuff. One thing I did, which was kind of fun, is something I've always wanted to do since the UNIVAC days, which was build a game of life. And this was the first program that I ever wrote using Cappy, the graphical thing. And, it's fun. It delivered code, of course, life.exe, and it's a fun thing to run. It's incredibly fast. You tell it the size of the life universe, and, it creates a classic torus, and off you go. But I would let this run for days, and, it would run, and blink madly, and little gliders and all that stuff pop up and wander endlessly about. But it worked. It never crashed, and that was meaningful to me. The red ones are the scary ones that still remain. Speed. I know you can't see this, but that's the hardware. That is the Crossspeed issue is, can Lisp do that? And I ran all kinds of test benchmarks on that. And the answer is yes. Number two, actually, it evolved to a more scary issue. Can the little Atom processor do this? Because you run the numbers, and we're clearly over the bandwidth internal to the chip, the North Bridge, South Bridge, whatever the hell all that stuff is. Anyhow, it's not enough power to do it. But then my view is, well, it's like building a bridge. There almost certainly is leeway there, and there was. And so it actually works and works well. People. This is an interesting one. My experience is that Lisp programmers, in general, tend to be extremely good programmers. I would argue the best programmers on this planet are Lisp programmers. I believe that. Not all Lisp programmers, including me, are the best on the planet. I am not at all. But I'm pretty good. But the best programmers I have ever met are astonishingly good. And those guys are in a different category than I am. But anyway, the other question I had about people was, well, that's true, but can you find them? And the answer is yes. My experience is that if you advertise Lisp jobs, a lot of people will come to your company and say, hire me, please, because there's not very many commercial job opportunities out there for Lisp guys. And guys like me would kill to be able to actually write code in Lisp as opposed to C and all the rest. And so the answer is yes, it is. Headaches. This is the only real issues that I encountered with building the system in Lisp. And I want to caveat this, that I think almost all of this has been fixed, or whatever you want. It's not a fix, it's an enhancement that gets rid of the issue in LispWorks 6. But the fundamental problem that I had was a learning curve, because building a true preemptive multitasking system running inside a Lisp environment is hard. It really is, for many, many reasons. And so, therefore, what you have is a non-preemptive multitasking environment where you control the comings and goings of the task yourself. A sort of thing where you spawn a task and it comes to life and does its thing, but you have, other than interrupts running outside, which typically you don't pay attention to, but you have control of the stream of operations running until you release it. And so you have to manually release that thread back, and so you get the multitasking effect. Okay, but then what that means is that things like sleep, they happily sleep, but it puts the entire system to sleep, not just your thread, but everything. And that was not intuitive to me, but once I figured that out, obviously it made sense. The other issue that's more subtle is here you are, you're running, in this case, on top of Windows XP. It is a true preemptive, hardware preemptive multitasking system buzzing away back there. So it preempts the entire Lisp system every once in a while and does whatever it's going to do. For example, updating the graphics on the screen. The graphics system here, Cappy, is actually built on top of the windowing system, which makes a lot of sense. But what you end up with is this interesting combination of your non-preemptive Lisp task running with a bunch of real preemptive OS tasks. And so there's all kinds of interactions going on between these two. And what all that translates into is the most difficult issue I had was getting the screen to update. And I would tell something to happen, and yet I did not have very good control over when that would actually happen, or in some cases even if it would happen. But then there's ways around that. But there's a learning curve to get through, and I would argue this issue is the biggest learning curve of building complex, and in our case, close to 100,000 lines of CL, but complex application-type programs. This is the biggest single issue to understand and get pounded in your head, and it's still vague in my head. I still have to worry about it. But the bottom line is this: no showstoppers. The obvious stuff, however, is, in my view, certainly my experience, is an enormous productivity gain using Lisp. All the libraries that are out there, that is very much a myth that there are no libraries. There are hordes of libraries. Incredibly bright people inhabit this world. I put them typically in the 99% percentile, really, Lisp programmers. And I know some really bright guys, to put it mildly, in this. And I think bottom line is there's no way that we could have built this thing in the time and with the resources that we were able to bring to bear if we tried to build it in C. I very much believe that. Anyway, that's what I have to say. Any questions? Very, very quickly, really. I was very careful how to do that, but give you an idea, the first order that I got for a system, it took us 18 months before we actually shipped the product. But that was a special case because it was a sheriff's office in South Dakota, and he called me and asked me, he knew I was in the fingerprinting world, and to my delight, he said, Mr. Harper, do you have a small portable device that costs $10,000, the fingerprints? And I said, oh, you mean a thing like this? And I emailed him literally the artist rendering. Seriously. And he said, oh my God, that's perfect. I want 3. And I said, well, that's just marvelous. Would you like some stock in the company? But anyway, kidding. But anyway, I literally got the order, and I told him, of course, in writing, look, we are developing this thing, and so understand what you're getting into. So I worked a deal with him. That department became the beta test site. And so I steeply discounted it even more. And then again, it took 18 months before we shipped, but that was our very first shipment. So if you're in the startup world, I urge, start selling about 20 minutes after you begin coding, but do it very carefully and make sure that they understand. Another point to that is, in a slide somewhere, I said time to market. There are really 2 steps to time to market. The very first step, and I said this, although I didn't put it this blatant, was time to prototype. And that's extremely important, because once you get a working prototype, then you can do magic things with that. You can go raise more money. And then the other phase 2 of time to market is, of course, when you ship to the end user. But there's no way we would have gotten to prototype stage as quickly as we did, which happened fairly quickly, in fact. And then time of a real product to market took by far longer. But that being able to raise follow-on money is at a decent valuation, so you don't have to give up all of your company, is a profoundly important thing.
All right, Jack. So my question is basically, because you're scanning the fingerprint, and then you're applying some kind of techniques, AI, machine learning, and so on, some algorithms to make sense of it, right? And then you're storing the result, and I'm wondering, so what happens when it comes to CURT? And, the fingerprint has to be verified. Can a competing system basically be used to also verify the fingerprint, because it also has to scan in the fingerprint again? And if your techniques are patented, right? If you have patents, then it must be basically your system to take the fingerprint in again.
Yeah. The thing to remember is that what we do is we collect the data that feeds the large national databases. In the USA, it would be the FBI, and like that. And so we populate those databases with what we generate. But in those databases, we really have no access to those. In other words, you do not use our system to look those fingerprints up in that database. We have no access to that. What we do, however, is we look the fingerprints up in our local database. But the thing to remember, if I understand your question correctly, is the data is inherently very fuzzy. Therefore, you do not do a pixel by pixel correlation match type thing. We don't do that. What we do is we look for so-called minutia. And if you think of a fingerprint, you have a ridge that comes up, a lot of ridges, and that makes up the print, but they bifurcate. They'll split and make like a Y, or a ridge will stop and then start again. These discontinuities like that is really what we look for, and those are called minutia. And so you calculate vectors to those from an origin, and so you end up with a set of vectors that are very fuzzy. So when you're doing a fingerprint lookup, you're running a compare against those in a very noisy database is really what you're doing. But it will locate, say, the 10 most likely print sets that make up the print that you're trying to find, and it will return 10 of those, and then you put those up on a screen, and a human fingerprint examiner actually looks at it and says, yes, that is a match. And so a pure machine lookup will not stand up in a court of law. But a human expert who's certified and all of that by the FBI and whoever, that does stand up in a court of law as a formal legal opinion. Did that answer your question? Okay. Yes, sir. Yes, the answer to that is yes, there is. There's all kinds of standards. The FBI has standards for storage. They use interesting so-called wavelet compression to compress the images, and then the transmission of digital fingerprint information goes against a very large 250-page standard put out by the FBI. It's very difficult reading. I've read it a number of times. I don't recommend it. It reads better backwards, by the way. But the other interesting piece is every state in the United States, of which there are 50, is different. They're based on the FBI standard, but every state is a slight superset of the FBI. They add things. For example, the state of Washington has a sex offender record that is part of their standard, that kind of thing. So it varies. Interpol in France, their standard they have is based around the FBI standard simply because the FBI came first. But and as usual, it's a superset of the FBI. So when we transmit into a new state, we must read those two standards and compare them together and understand what that superset issue is, and then build a special version of the thing for that. Therefore, we have 51 standards in there. If you're in the state of Washington, it knows about sex crimes of various forms. If you're talking to Interpol, it knows other things, that sort of stuff. And it varies. And it's a real problem. Yes. Fingerprints are remarkable things. The first electronic fingerprinting system that I worked on, to my amazement, was in 1974. Yeah, at the university that I went to, University of Houston, EE department. There was a professor there who had a contract from the Houston Police Department to build this thing, and it did not work very well because it was so primitive. But I vaguely, it's 40 years ago, but I vaguely remember that issue coming up then. However, today, I do know that there is no problem at all with digital fingerprints. They do stand up in court. In fact, they are expected to be digital. And in the United States, the federal government is pushing hard to get away from the old ink and roll, so-called. I don't know if you've been printed. I have a number of times, but it's a mess, with ink. But problem is you smear it. Very easy to do. And so they submit the fingerprint card, and something like 20% are rejected because they're not readable. And of course, by that time in the U.S., we have habeas corpus, where you cannot hold a detainee longer than typically 48 hours without a charge. So you release somebody because you did not know who they are. A murder, arrest warrants out, all that stuff. And it's very common. They book them out on habeas and off they go. And then a month later, they get the rap sheet back from the state authorities as to who the guy really is. And it's a real problem. And therefore, the United States federal government is pushing hard to get rid of all the ink and replace it with pure digital systems. The other thing about fingerprints is there has never, ever been two people found out of, 7 billion people on this planet that have the same fingerprints. It's never happened. Third thing is that fingerprint evidence, if it's collected, a forensic fingerprint, meaning that it's collected in a controlled environment by a trained person has never been thrown out of criminal court as evidence. Now, it has happened if the so-called latent fingerprints collected at a crime scene were not handled correctly according to the rules of evidence, etc. But if you follow the rules, then it always stands up in a court of law, including the digital form. I would, productivity gain, question. Productivity gain, is it limited to the AI side, or is it across everything? As an old Lisp programmer, and also I've written a lot of C and enormous amounts of assembly language, which doesn't count, many years ago, C compared to Lisp, I would argue that the Lisp, if you're writing non-AI, you still get that enormous productivity gain. And my view of why is because of the programs as data phenomenon. I mean, macros and levels of abstraction. But my experience is that a single line of Lisp very easily can replace, 30 lines of C, depending on what you're doing. But I mean, that's what I see, definitely. Yeah. Yes, sir. Yeah, I agree. How do you compare something to assembly or COBOL? I mean, COBOL, I guess, is still used somewhere, but assembly, obviously, in little pieces. But in the real world, I agree. You're correct. You should compare it to things like that C# and Java and all those guys. The answer is I have no direct experience in C#. I've avoided it like a plague. I tried reading several books on it and was just horrified by the mind-numbing aspects of things like C#. I just don't think like that. It's a fundamental problem. O dog, you trick. No. You dog, O trick, something. One of those does not apply to me, clearly. So I don't know, and I cannot compare C# or any of those things to Lisp. I'll tell you one thing. I installed whatever it's called, .NET, whatever, from Microsoft on my PC, and it was, I think, a 16, I believe, gigabyte download. It took 3 weeks. Thing crashed endlessly. It slowed down literally by a factor of 3 was my experience. Anything with that level of overhead has got to be just awful in my view. And I'm running out. One more question. Anybody? Yeah. Yes, sir. Oh, no. Yeah. Okay. Thank you very much. I appreciate it.